NASA has revealed the design of SpaceX's Starship cargo lunar lander, which is a major step forward for the agency's goals for lunar exploration. With this breakthrough, NASA's audacious plan to return to the moon in the next years takes a significant step forward. The sleek and futuristic look of SpaceX's Starship lunar cargo lander embodies the state-of-the-art technology that the company is recognized for. The lander marks an important advancement in lunar exploration capabilities with its sleek design and cutting-edge technology. There will always be difficulties and possible problems to resolve, just like with any complicated technical job. Despite its amazing design, the Starship lunar cargo lander may confront technological, operational, and economic challenges. In this video, we'll examine the specifics of the Starship lunar cargo lander design in more detail, highlighting its novel features and evaluating any upcoming difficulties. The journey back to the moon. With the engagement of new players like China, India, and Japan, the journey back to the moon is now propelled with renewed excitement, more than a century after NASA's last successful human landing mission. But it's obvious that the US will win this race, especially with the backing of innovative businesses like SpaceX and Blue Origin. As part of the initial plan, SpaceX's Starship HLS version is set to land humans on the lunar surface. But the Starship cargo lunar lander is another important factor to consider. This version will be responsible for crewed rovers' safe transportation and landing on the lunar surface's rough terrains. NASA announced its strategy on January 9th. NASA asked SpaceX and Blue Origin, the producers of the Artemis human landing system, to employ their knowledge acquired from constructing for future systems to potentially transport significant payloads on future flights. This move demonstrates NASA's innovative strategy of utilizing the skills and resources of its partners to innovate and evolve, which opens the door for more missions involving lunar exploration. We're getting closer to solving the secrets of our planetary neighbor as SpaceX and Blue Origin continue to advance their capabilities and the possibility of sending heavy payloads to the moon's surface. This new requirement set by NASA marks an evolution in the contractual obligations for both SpaceX and Blue Origin, building upon the foundation of their previously awarded contracts. Now, the focus is on developing a cargo ship that can potentially deliver payloads weighing between 12 and 15 tons or 26,000 to 33,000 pounds to the moon. Crucially, this cargo version is supposed to be deployed before Artemis VII. These cargo versions, according to NASA, will be based on the human landing technologies that are presently being developed for Artemis 3, 4, and 5. The main focus of the modifications will be on modifying the landers to accommodate payload interfaces and deployment mechanisms without including human life support systems. SpaceX's Starship cargo lander will remain largely unchanged from its predecessor. It will still include a payload door for opening and deploying payloads, with small enlargements for larger payloads like rovers. Additionally, the Starship cargo lander will continue to use an elevator system similar to the Starship HLS. The system will lower the rover from the lander to the lunar surface from a significant height. The design of the elevator system is unknown, but it may include door and barrier systems similar to the crew elevator, or it could use ropes for gradual descent. We eagerly await more information from SpaceX to clarify this part of the mission. Because of the Starship HLS's payload compartment's height of around 18 meters and diameter of 9, which results in a volume of more than 1,000 cubic meters, a Starship cargo lander can carry at least 3 pressurized crewed rovers per landing. This is perfectly possible in order to allow the Starship cargo lander to carry 3 or more rovers. We still don't know the exact mass of each rover. NASA's requirement is 12 to 15 tons before Artemis VII, which means the companies will have 4 missions to do that, and each mission will have to carry 3 to 4 tons. That doesn't seem to be too difficult for SpaceX and the Starship cargo lander because the original Starship can carry up to 150 tons of payload to LEO. If landing on the moon, it might be a little less, but it would still be sufficient to satisfy NASA's standards. As a comparison, the Blue Origin's Blue Moon will not be able to match the capabilities of the Starship cargo lander. Blue Origin unveiled the 16-meter Blue Moon Mark I version in October of last year. However, because Blue Moon's design isn't entirely optimized for payload, it might not be able to accommodate 3 rovers or less, maybe just 1 or 2. Fortunately, Blue Origin still hopes that every Blue Moon flight will be able to deliver 3 tons to any location on the moon, giving us confidence that it will be able to fully satisfy NASA's standards. Challengers, For SpaceX's Starship cargo lander, stability on the lunar surface is an essential factor that must be taken into account in addition to payload design. In fact, this problem has become much more prominent as a result of multiple lunar missions that took place from late last year to early this year, all of which had problems with lander stability. The Artemis missions face technological obstacles and the risk of tipping over on the lunar surface due to its natural properties, especially in the southern polar zone. Extreme temperatures are common in this area, reaching 240 degrees Celsius or 400 degrees Fahrenheit, which can have a major effect on electronic devices. Moreover, landing vehicles face a great deal of difficulty in this rough terrain that is dominated by a major volcanic system. Due to its diameter, the Starship finds it increasingly difficult to maintain balance, and in the event of a crash, there would probably be no way to continue the mission. To reduce these risks, SpaceX should emphasize developing safe landing legs. However, the path to improvement in this area remains uncertain. Finally, by upgrading both the navigation and engine systems to enhance precision and control, SpaceX can increase the likelihood of successful landings. So, what are your thoughts about today's video? Remember to leave them all in the comments section below.